Okay, for this first part, so go ahead and grab your notes and your assignment out because we're going to go back and forth between your notes and your assignment today. So the first part, I'm just going to have you listen up here. There's not a lot to look at as far as notes up here, but I want you to listen to what we do so that you know how to do the first part of your assignment. Okay, and by the way, for the first part of your assignment, there are colored pencils over here, many different colors. It might be helpful to grab them when we break to do the first part of your assignment. Okay, so the first thing that we want to do is graphs tell stories. Graphs tell stories. And so we're going to do some funny graph stories to start with. Cats versus the hotness of a girl. So here's a 0 on a scale to a 10 with 5 somewhere in the middle. Okay? And, huh? Have you seen this video? I have not seen this video. The video of the crazy scale over there? I haven't. I'll have to look it up. Is it on YouTube?
Oh, it's not like a girl.
What's the name of it? What do I research?
It's just called like the crazy scale or something.
The crazy scale. Okay, well, we'll be working on a lot of crazy scales today. So, well, across the bottom, so on this is a hotness. Okay, and on this one, we're going to put number of cats. So 0, 1, 2, 3, 4, 5, and more than that.
Like the graph was like that. It was like how hot she is versus how creamy she is.
Right. This is what it's going to be here. So do lots of cats make people crazy or not? Okay, so where do you think we should start? There's a lot of other factors we could factor in. We're just going to make our own little graph. Where do you think I should start with 0 cats? General hotness of a girl. A 10. We got a 10. We got an 8. Where do you want me to start? 2? Oh, you can leave. I'm just kidding. Okay. Start at 7. Okay, we'll start at 7. Okay, so then I have 1 cat. Is it going to go the same, higher, lower? What do you think? Higher. Okay, higher for 1 cat. Just 1 cat. Okay, now 2 cats. 2 cats. Drops down to 3? Goes back. I hear it goes back down to this for 2. Okay, goes back down to this. So I'm going like this. Okay, what if I have 3? 4 or 5. Okay, we're going to go down to 4 or 5 for 3. What about 4?
0.
0.
And then it just flatlines.
0 and then it flatlines. Okay. All right, so this is an opinion graph, right? Everybody has a different opinion. We had lots of different things going on. But this graph tells a story of some of us. Okay, not all of us, but some of us. If you're a cat person, it might be a lot different graph than what is up here. If you're a dog person, it might be even different. Okay, so let's look at another graph. So this, we're just going to work on graphs tell stories, and this is a story we told. So this person, you know, we think 1 cat's okay. In fact, it actually, you know, makes it more attractive, and then we get to 2 cats, and now we're back down to sort of normal, and then after that, we sort of fall off the graph. Okay, so bye-bye, crazy cat lady. Okay, so next one. Here's another funny one. We're going to do mental health. So mental health up the side. So this is 100% normal. This is not even close. This is 50% of the time you're sane. Okay, so we're going to use 2 different lines here. We're going to do number of cats, we're going to do in blue, and number of teeth we're going to do in red. Okay, so let's do the number of cats first. So going across the bottom, I'm going to go 1, 2, 3, 4, blah, all the way up to 32. Okay, so what do you think? Where do I start? 1 is 100% normal. So what about 0?
1 or 3.
Is 0 100% normal?
Yeah.
Okay. Oh, and you said it's 90% normal, so we got some of that going on. Okay, 2. 80, around 80, okay, around there somewhere, okay. And what about 3?
Are we talking about missing teeth?
Mental health with cats. We're going to put 2 graphs on one thing.
Oh.
So we got now 3 cats. No, 4 cats. We're up to 4 cats.
4 cats.
40%.
40%. Boy, we're dropping 40%. Somewhere in there. Okay. Okay, let's go out to 32 cats.
62.
62% mental health?
You're insane.
Okay, so we're down there. Okay. Now let's look at the teeth. No teeth.
0%.
If they have no teeth, I would say they're at
You think they're 0? What about this guy? He looks like he's really smart.
Babies are pretty normal. Babies are pretty normal.
Yeah, what about babies?
20.
Okay, babies are cute. Oh,
Mental health. Where are we going to put it?
20%.
We're at 20 or 50. I've heard both. So 50%. We'll say 50%. 1 tooth. Are we going to consider it baby or we can consider it older people?
no, let's do like mid-range of like 20 to 40.
20 to 40. Okay, they have 0 teeth and they have 50%.
Well, what's
Depends on the situation.
Okay, anyway. All right, what?
1 tooth is 15%.
15%.
Probably like those crazy hobos at New York that endorse that.
He's an old wise wizard.
Okay, what about 2? I know this is the most talkative you guys have been for a while. Okay, what about 2?
2 teeth?
2 teeth.
SpongeBob is like a good 12.
12%. So we're going to go there. Okay, 3.
I think it's just it's tricky.
Until you get all your teeth?
Unless you have like the front rows.
Counts your points.
Once you have your front
28.
row.
Once you get to 27.
Yeah, your front 6.
6? Okay, when I get to 6, where am I going to be? Back up to 50% or higher? Okay, 50%. Then what? When I get to 28, 27, where am I going to go? Okay, still going up like that?
Yeah, and 31 is all the way down to 0 because you're a hillbilly.
Wait, what if you have 50?
Yeah.
Why are you a hillybilly?
1 tooth. Hey, what if you have 30?
Oh, it could be one of the back ones like your wisdom teeth.
What if you have 30 but you are missing the front 2?
I don't know. See, there's a lot of different variables, right? So we're going to tell a story with a graph. Maybe we tell a story about older people with losing their teeth, or maybe we're talking about a baby that's gaining their teeth and they're gaining in intelligence. So there's a lot of different things we can do with this, right? But we've got to be able to give more information than just X and Y axes and what's going on, right? Because if somebody looked at this graph, they'd go, okay, I got another one for you. Need to pee, need to sneeze. Okay? And this is versus time. So here's time on this axis, going that way. And this is low versus extremely high. This is my need. Okay, so need to sneeze. You sort of go like, and you're going to sneeze. Well, sometimes you go like this, right? Hold it back. Some people, my husband swears by that, but I don't. Okay, so next one, need to pee. Sort of same kind of thing? Or does it escalate straight? Does it have these little waves that you... It's just a linear? So it does sort of have a little wave here when I don't think about it, but it still is escalating, and all of a sudden, what happens? They meet, and we have a disaster. Yes.
Oh. Say it's more like an exponential graph because you're like perfectly fine for like a good couple hours.
Okay, so it could be an exponential, and all of a sudden, Okay, all right, so there's different ways we could put it. It's a okay, so what I want you to do is I want you to talk to your lab partner. If your lab partner's not there, then work with somebody that's right next to you and work on the first 3 graphs in your assignment. You can grab the colored pencils. We're going to give you 15 minutes, 5 minutes a graph, and we're going to come back together. Okay, so I would like to see some color in there. I'm going to pause. Okay, back up here with me, with your notes. Okay, we're going to be looking at some graphs, and graphs tell stories. Shh. Come back to me. Graphs tell stories, and you need to be able to read a graph for the ACT, the SAT, many college tests. You need to be able to read graphs. The graph that we're going to work on today is called activation curve graph, or a heat graph. And this graph tells me if something is exo or endothermic. And we've been working with exo and endothermic. What was exothermic? It gives off heat. So from where the reactants were to where the products are, it gave off heat. So if this is my energy or my heat on the y-axis, then I'm going from the reactant here to the products here. This becomes a negative delta H. That negative delta H tells me that heat was given off. So this graph right here is an exothermic graph. Okay? The other one over here, if I'm looking at my reactants to my products, I actually had to increase the energy amount. Because I increased it, delta H is positive, and this is an endothermic graph. Okay? Now, how I figure that out is I always go from my reactants to my products to get that change in heat. Okay? Most of them will have numbers over here, so I can actually give a number. It gained this much heat or it lost this much heat. These first graphs we're using, we're just going to label some things. I can also label from where my reactants are to the top of the curve. That's known as E of A, or activation energy, or energy of activation. Okay, it's known as both activation energy and energy of activation. That's from where my reactants are to the top of the curve. So over here, my E of A is from my reactants right here to the top of the curve. That's E of A. Okay? Now, as I'm going along, this is time, or it's also called reaction progress. So as I'm going along and moving along the reaction, I get to the reaction complex, or finish the reaction. Now, how many of you watched The Grinch That Stole Christmas, the cartoon one? Okay, remember when he goes down and he takes all those toys and stuff and he piles them on a sleigh, and the poor little dog has to pull him up to dump it, and he's right at the very top and he's waiting to dump it and he's listening. Remember that? That's like the top of the activation curve. We call that right here the activated complex. At this point, it can go either way. It can go back to the reaction, or back to the reactant, or towards the product. And I forgot to turn this timer off. Yep. It's running. Okay, so that activated complex is the top on both of them. Now, if I want to find the energy total needed for the activated complex, I'm going to go from the bottom of the graph all the way up to the top. That is going to be the energy for the activated complex. Now, I've drawn E of A inside the curve, but it could also be drawn outside the curve. So I could have gone across like this and said from the reactants all the way to the top of the curve, that's also E of A. It's the same thing. So in some graphs you'll see it inside, in some graphs you'll see it outside. You need to know it's still E of A. Okay? We talked about negative delta H for exothermic and positive delta H for endothermic, the activation energy, the activated complex, reaction pathway, or progress. Okay, and on the side is the potential energy, often measured in heat, but it could be any kind of energy. We talked about different kinds of energy. How many of you remember what kind of energy we could have? That was that first day. What kind of energy were we talking about? Light, heat, sound, right? There was a lot of different ones. Okay, so let's go to another one here. Let's take this blank one. This is giving me a delta H. Is this delta H positive or negative on this one?
Negative.
Negative. How do you know? Because the reactants are higher than the products. Okay, and you got to think of this as 0 to, as far as potential energy gets higher going up. Okay, so where do I measure my activation energy? We're going to label everything we had on these other ones. Okay, it goes from the reactant, so I can go here or here, all the way to the top, whatever it is. That would be E of A. I can measure it inside or outside the curve, right? I just need to know the difference between the reactants and the top. Okay, what else did we measure on the other graph? What other part did I need to identify? The activated complex. So up here at the top, we've got the activated complex. And the total amount of energy for the activated complex is from here all the way down to the bottom of the graph there. Okay? Now, there's one other thing that we add. How many have ever watched Fiddler on the Roof?
Oh.
I know. Some of you really like it, some of you don't. Okay, there's this old lady that's sort of a busybody and goes around and does something. What is she called? The matchmaker. I'll give you a hint up there. Okay, and they sing that song, Matchmaker, Matchmaker, make me a match, find me a find, catch me a catch. What does the matchmaker do?
Like finds a woman for the guys and finds a guy too.
Okay, a good matchmaker would get a list from the guy and a list from the girl, and they would try and match up what things they wanted in the opposite. Okay, so a matchmaker basically puts together like souls. We call that a catalyst in chemistry, and a catalyst basically gets things together with less energy. So I originally needed this much energy for the reactant. So it's like going up and over a mountain. Well, if you're smart, there's a way around the mountain that might be not as much energy than going straight up and over, right? So a catalyst actually takes and makes a lower amount of energy. It still has an activation energy, but it's a lot lower. Okay, that is my catalyst right here. This is my catalyst pathway, my easier way. It still has to have some amount of energy that was put in. It can't go like this. It can't start the reactants and go straight to the products. That's non-existent. That doesn't work. Okay, it still has to have some amount of energy that is put in. Okay, does that make sense? All right, yes?
So, like, even if it was any energy lower, like the smallest decimal lower, it would still be a catalyst?
You'd still have to have a catalyst to make it any lower, yes. Okay, so a reaction has to happen a certain way. In chemistry, we have to orient the molecules so that they go together and they actually react. It has to hit with the same amount of energy needed to break the bond and reform the bond. If I hit with too much, it doesn't work. It's sort of like asking a girl out on a date, okay? If you come up to them and go, hey, you're really cute, would you like to go out with me? They're going to go, oh my, oh, right? They're going to go, no. But if you come up and you're really shy and like, I'd like to go out on a date with you, they'd also, the other guy would probably go, whatever. So you have to have the right amount of energy, right? And you can't ask a person out on a date if you're facing the opposite way than what they are. Hey, would you like to go on a date? Who are you talking to? Right? So you got to be oriented correctly. So you've got to be the right direction. You got to have the right amount of energy. Same thing with a catalyst. Okay? A catalyst sort of says, okay, you and you're going to get together, you're going to talk, and you're going to make a reaction. Okay? All right, so let's go forward a little bit more. This is now a graph where we actually added the numbers. And you can add the numbers in, and we can actually get numbers off this graph. So what is the enthalpy? Enthalpy is delta H of the reactants. So what is the energy of the reactants? Where are the reactants? Right here. Right? These are the reactants. So the reactants are, good, so we put 20 kilojoules per mole right here. What is the enthalpy of the products? Where's the products? Right here, products. And the products are 50. So we put 50 kilojoules per mole here. What is delta H? What's the change? Delta H was from the products to the reactants, right? This is a, what kind of reaction? It's endothermic. So we can answer that one down here at the bottom. This is an endothermic reaction. Because it's endothermic, delta H has to be a positive. I'm going from 20 to 50, so I added 30. So it's a positive 30 kilojoules per mole. Okay? I could also ask you, what is the energy of the activated complex? So we might want to add that on. What's the energy of the activated complex? That's right here. So it is 100 kilojoules is the energy. Okay? And we could put per mole. So there's a bunch of things I can get off this graph. You need to be able to pull those things off the graph. Okay? Pretty easy, right? Pretty easy. So review real quick. We can now use a graph to tell a story and get information off of it. You have assignment 7.3 that is due next time. Finish it before the end of the period. Come get a stamp. I am not going to wander around to this time because it's fairly easy and they finished really fast. Okay? If you have questions, though, you're welcome to come up and ask. All right? Get going. Let's get those stamps for an extra credit point on your assignment.